Okay, so if you have a to the power m over n like this here, this is the same as a to the power 1 over n multiplied by m like this here. Then this here is the same as the nth root of a like this raised to the power m like this here. So now let's try to apply this on a fraction. So if you have a over b like this to the power m over n, this here is simply going to be a to the power 1 over n divided by b to the power 1 over n, and we have our m outside there. So here it's the same as we're looking for the nth root of a divided by the nth root of b and everything to the power m like this. Okay, so now that we've established this side here, let's go ahead and try to solve this question that we have there. So this side here we have so that's basically going to be 8 to the power 1 over 3 divided by 27 to the power 1 over 3 and everything here the power 2 like this here. So then we know that now if anything is raised to the power 1 over 3, we're simply just looking for the cube root of that number. So this simply means that we're looking for the cube root of 8 divided by the cube root of 27 like this here. Then everything we raise to the power 2 that we have there. So the cube root of 8 simply tells us that we're looking for a number such that if we multiply that number by itself, we're going to get, if we multiply that number 3 times by itself, we're going to get 8 there. So that number there is going to be 2. So 2 times 2 times 2 gives us 8. So we're going to have 2 here. Then the cube root of 27, we also look for a number such that if we multiply by itself 3 times, it's going to give us that 7 in that number, or it's going to give us 27. And that number there is 3 like this here. Now remember we still have this power 2 here, so we say the power 2 here. So this is the same as 2 to the power 2 divided by 3 to the power 2 here. So this will simply give us 4 over 9 like this here. Okay, so we just need to apply the properties of indices here. Then after doing that, we evaluate and we get the desired results there. Okay, let me scroll down so that we look at question number 2 here. So for question number 2, we have simplified 4 open brackets x minus 2 plus, okay, so there's a plus there, plus 3 open brackets 2x minus 3 like this here. So 4 times x we get 4x, 4 times negative 2 we get negative 8, plus 3 times 2x we get 6x, 3 times negative 3 we get negative 9. So here we put the like terms together, so I have 4x plus 6x minus 8 minus 9 like this here. So these are like terms, we can add them together, and these are like terms, we can add or subtract them like that. So here 4x plus 6x we get 10x minus, since this is a negative and a negative this side, so I mean that if it is on the number line like this, if this is our negative 8 here, minus 9 simply means that we count 9 times going to the negative direction this side here. So if we count 9 times going this side, we're going to land on 17. So I mean that here, negative 17 like this here. So therefore, that is our solution there. Okay, let's also go to number 3. Solve the equation. So for number 3 here, we have solved the equation 3x minus 5 and x plus 2 equal to 0 here. Now, what this simply means is that when you're solving a quadratic equation and you reach at a step where you say you have, for example, you have x minus a and also maybe x plus b here equal to 0 here. So this is a quadratic equation that has been factorized already. What this simply means is that x minus a here should be equated to 0, and also x plus b here should be equated to 0 here. So we do the same thing here to this question that we have there. So mean that here we're going to have 3x minus 5 equal to 0, or we have our x plus 2 equal to 0 here. So here we transpose this, negative 5 is going to be positive 5 this side. So we're going to have 3x equal to 5. Then this side we're going to have x equal to, if you transpose positive 2 on the other side of the equal sign, it's going to be negative 2. So we're going to have a negative 2 here. Then this side we divide by 3. We divide by 3 on both sides. And then we have that our x here is equals to 5 over 3, or x is equal to negative 2 like this. Okay. Let's scroll down. We'll go to the next question here. Okay, so we go to question number 4 that says factorize completely 7x squared minus 7 there. So we need to factorize completely 7x squared minus 7 here. So the first thing that we're going to do here, okay, so the first thing that we're going to do here is we factor out the common number that we have here. So factoring out the common number that we have there, we're going to have 7 is common there. We remain with x squared minus 1 like this here. So now this is a difference of 2 squares here. So what we mean here is that if this is a difference of 2 squares, so for example, if you have x to the power 2 minus a to the power 2 here, this here is the same as x minus a and also x plus a like this here. Because when you multiply x and x here, we're going to have x squared, then we have plus xa minus ax here, then minus a squared like this. So this here will cancel. You're left with x squared minus a squared like this here. So we apply the same principle here on the question that we have this side. So I mean that this becomes 7 here, open brackets, x minus 1 and also x plus 1 like this here. So this here we factorized completely there. Okay, let's go to number 5 there. So number 5 says use set builder notation to describe the shaded region in the Venn diagram below here. So first things first, we're going to describe what the complement of a set is. So the complement of a set simply refers to everything that is found outside a given set there. So what this simply means here, if this is our universal set here, like this, and this is our set A here. So if we say A complement, we're simply talking about this region that is outside A like this here, like that. Okay, so now when you look at this set that we have on the right hand side of the screen here, which is on question number 5 there, you'll notice to say that there's a complement that we have outside there. So mean that, that we have there. So mean that we're considering things that are not in A there. So first things first, we have our A complement there, like this here. So A complement simply means everything that is outside here. So now if you notice what is outside there, you have 2 sets now. So let me include the 2 sets that we have there, like this. So if that is our A, that is our B, and that is our C here. So now I'll use different colors for this. So A complement is everything. So this is our set A, this is our set B here, and this is our set C here. So I'm saying A complement is everything that is outside the set A like this here. Okay, so that is the first part there. So now when you look at this set that we have here, the only shaded region that we have there, I'll use a different color for that one. So the only sorry, let me scroll up a bit. Okay, so the only shaded region that you have there is the set B that you have here, like this, and C there, like that. So now, if you check here, A complement, meaning that we don't list anything that is in A, we just list everything that is outside B there. So everything that is outside B also contains B and C here. So now, how do we do this? We know that if the two sets A, B, and C here have been shaded, it simply means that they form a union of the two here. So I mean that there, we're going to say we have open brackets here. We know that we have B union C like this. Now, we have everything that is outside A here, okay? And B union C is the only thing that's being shaded there. So meaning that this here simply gives us the intersection of the complement of set A, which is everything that is outside A, and the union of the two sets B and C here. So meaning that here, describing this set in set builder notation here, we just simply have A complement intersection B union C like this here. Okay, let's look at question 6. I think we'll end on question 6 in this series, and then we'll look at other questions in the next video then. Okay, so we have that a businessman got 800 shares with 7,200 kwacha. What is the cost of each share there? Okay, so here we're going to do direct proportion here. So meaning that here we have, if 800 shares that we have here, they come from they cost 7,200 like this here. So what is the cost of each share? So what is one share, or what's the cost of one share? We say 1 goes to x like this, because we don't know what x is there. So here, cross multiplication, we're going to have 800x here is equal to 7,200 like this here. We divide by 800 here. We also divide by 800 there. So these will cancel. We have that our x here is equal to 7,200. Let me scroll down a bit. So we have 7,200 divided by 800 like this here. So since we're not allowed to use a calculator here, what we're simply going to do here is we cancel the zeros here. So the zeros cancel. We're left with x equal to 72 over 8 like this here. So now, how many times does 8 go into 72 here? We know that 8 can go into 64 8 times. So if you add an 8 to 64, we're going to get 72. So meaning that here our answer is simply going to be 9 there. So therefore here, the cost of each share there is simply going to be 9 kwacha like this here. Okay, thank you. Look out for the next video in the series that we saw from question number 7 up to somewhere question number 15, and so on and so forth there.